The second moment of area has a similar expression to the centroid of a section, but it involves a square of the moment arm. And it comes up as a geometric quantity of a section in resisting a bending stress. So for example, if a stress is applied to this area, and it's a vector coming out of the plane, then it can cause bending rotations about the x-axis and also about the y-axis. So the resisting quantity for bending rotations about the x-axis is the second moment of area about this axis, which involves the square of the moment arm multiplied by the differential area, and it's integrated over the area of the section. And similarly, the second moment of area about the y-axis has a squared moment arm of x squared. Now if a stress was applied in the xy plane, such as a shear stress, well, this can cause rotations about the z-axis. So if we consider this distance as r, then by Pythagoras' theorem, we have r squared is x squared plus y squared. And if we integrate this over the area of the section, then we obtain the following expression on the right hand side, which is x squared plus y squared integrated over the area. And if we break up the integral on the right, we obtain a moment of inertia about the y-axis plus the moment of inertia about the x-axis. And this quantity here is the polar moment of area, which we denote IZZ, which is equal to IXX plus IYY. Now if we consider this example, and we want to find the second moment of area about the horizontal axis, well, we break this section up into infinitely thin rectangles, and these have a thickness dy, and the section has a width b and a height h. So therefore the differential area is b dy, and we multiply this by y squared and integrate this from minus the height on 2 to plus the height on 2. And if we take b outside the integral, then we obtain y cubed on 3 evaluated from minus h on 2 to h on 2. So that gives b by h cubed on 3 by 8, which is 24, minus negative h cubed on 24. Which gives bh cubed on 12. And that's a well-known second moment of area for a rectangular section about the horizontal axis. And I'll leave it for you to verify that the second moment of area about the y-axis is equal to hb cubed on 12. And you can verify this by taking your infinitesimally thin rectangle in the vertical direction and integrating over x. Please subscribe, like and comment to help me reach more students.